Hi friends, it gives me immense pleasure to come for this course, which is Aircraft Stability and Control. Today I am in lecture number 25, and this is about reversible control, stick free and trim tabs. I am going to discuss very extensively in this topics of trim tab. It is very interesting. Please be with me. In this, I am going to discuss something in this lecture, something about Man Ki Baat, then reversible control, then trim tab. And in this lecture, I am going to answer some questions like what is reversible control, and next is need of trim tabs in aircraft control. Okay, so these trim tabs are there for all three types of control: elevator, ailerons, and the rudder. Okay, it is a small component, and this we are going to discuss in detail in today's class. Be with me. So, Man Ki Baat, we have discussed till now about aircraft longitudinal static stability, aircraft lateral and directional static stability. In that, we have discussed about the elevator deflection, then aileron deflection, rudder deflection, etc. And this thing we have discussed on stick fixed case. But now we are in the process of stick free case. Stick free case tells about how much floating of the controls happening due to aerodynamic effect. You know that whenever any object is flying and any airfoil, it will generate some force. This force we have not considered in our stick fixed case. But in stick free case, we have to see that how much forces it is developing. So that much force pilot has to apply to counter the aerodynamic forces. So here we are going to discuss these all issues. So stick free concept is true for reversible control only. By pulling the control stick, elevator goes up, and by pushing. Oh, what is the meaning of pulling? Just you can see, this is the stick and this is nose. So if I am pulling like this is in my side, if I am doing, it is a pulling, and if I am doing like this, it is a pushing, and it is a pulling, and this is the pushing. So if I make the stick towards me, it is a pull, and if it is away from me, it is a push. So that we have to understand. So by pulling control stick, elevator goes up. So if I do like this, elevator will go up, and by pushing the control stick, elevator goes down. And if I push it, then control elevator will go down. Control elevator will go down means elevator will go down, then it will generate upside lift. So for more CL, angle of attack to be increased. If you want to do more coefficient of lift, then angle of attack has to be increased. Elevator goes up during reduced speed. So if you want to speed to be reduced, then elevator has to go upward. Pulling the stick, the speed is reduced. If you pull the stick, elevator go up and speed will be reduced. Stick free concept is strictly valid for reversible control. Elevator down means stick is pushed forward. If elevator is positive angle, then you are pushing, means making stick forward. Okay, that is the meaning of pushing. So if I want to fly at particular coefficient of lift CL, the DCM by DCL fixed. This gives what sort of elevator required to trim the aircraft. The DCM by DCL free gives feel to the pilot so that he or she can apply a particular force to get the feel of control for how much stick force is required. So the feeling of the pilot is also important. that he feels that how much force is required. So he can understand that aircraft is in which speed or which CL my aircraft is flying. So that is also very good essence. Without seeing the instrument, pilot will assess that aircraft is going in high speed or the low speed, the coefficient of lift is high or low. It can feel by this force which is applying on the stick. If the pilot hold the stick hours together, it will make the pilot to get tired and their energy will be used for holding the control only. Okay. So he will be continuing hours, 2 hours, 8 hours he is putting, he will get tired. So we need a trim tabs are required which makes stick force 0, Fs 0. So trim tabs are required. To maintain the given trimmed condition, so pilot can go hands off. He will just leave the stick and he will be free. His hands are free. He can think something new. He can take charge for any emergencies. He can handle. Pull means reduced speed. Pull means in my side, if it is I am pulling like this, it is reduced speed. In this elevator will go up. Push means increased speed and elevator goes down. Pulling means reduce speed, elevator will go up, and push means increase speed, elevator go down. So if elevator is going down, speed is increased. That we have to understand. Okay, so this Man Ki Baat is completed. Now I am coming to the topic which we have already, this thing I have discussed already. So here this reversible control is stick force. In reversible control, we can give feel to the pilot that how much stick force is required for particular flight condition. How much control stick to be used for a given condition. This you can feel, the pilot can feel this thing. So here we can see that for CL, it is dCm by dCl fixed and delta E is equal to, we have already discussed that delta E is equal to delta E naught plus minus dCm by dCl fixed by Cm delta E into CL delta trim. These equations we have discussed a lot of time and this is very important. How much elevator required? This is required elevator. So this elevator, how much required? We have discussed so much time. Models for stick free is developed for stick free condition. So trim tab concept was introduced. So in the previous, we have developed this thing that delta E float is equal to minus CH alpha T divided by CH delta E. So here this alpha T is trim tab, angle of trim tab here, and here also it is a trim tab. Okay, angle of attack of trim tab. This we have already discussed in our previous classes. Okay, so now basic difference between CH alpha T and CH delta E. Very important parameter here. So we should understand that CH alpha T and CH delta E. What is the CH alpha T and what is CH delta E? You know that CH means it is a hinge moment coefficient. Alpha means angle of attack and it is for tail. Okay. Delta E is this. CH is hinge moment coefficient of deflection of elevator. Delta E is a deflection of elevator. So CH alpha T means dCH by d alpha T. Okay. So CH alpha T means it is a dCH by d alpha T. It is the differential of hinge moment coefficient with respect to the change in angle of attack of tail. Okay, so it is alpha T is tail. So d alpha T means it is a differential in tail angle of attack. And CH delta E is equal to dCH by d delta E. It is the change in hinge moment coefficient with change in elevator deflection angle. Okay, it is very much clear. So if CH delta E less than 0 or negative, if CH delta E is less than 0 or negative, it gives a restoring hinge moment. Okay, so it is very much important that CH delta E, if it is negative, it is giving restoring hinge moment as it is negative. We can see in the diagram here that when elevator deflected downward, here deflected downwards, delta E positive, a force will be generated upward and the hinge moment CH is generated, which opposes the pilot effort as hinge line HL is ahead to CP. Okay, so CH will be opposite to the deflection of delta E. Try to neutralize delta. Very important parameters, just you can see here. What is the meaning of this? This is your tail, this is your elevator here. Pilot has applied a force Fs so that it has deflected downwards. Okay, so he has to apply a push force. So he has applied a push force, so it has come down. As it has come down, so angle of attack, this thing has increased and it will generate a additional lift force upward. This lift force, as CP is behind HL, it will generate a negative CH. A negative CH will be generated. This negative CH will counter the moment which is applied by the pilot, and pilot will feel that he has not applied any force. Okay, so that is the beauty of this system. Okay, now I am discussing about the trim tab and what is the principle behind the trim tab. Okay, so what is the function of trim tab? This we are going to answer. For trim, the meaning of trim is what? Lift is equal to weight. This is the RCL trim, means aircraft is flying at designed trim condition. To maintain this, pilot to hold the control stick continuously, otherwise aircraft come down. If elevator is deflected upward, it will develop a force delta LE downwards. If elevator is deflected upward, a delta LE downwards, and elevator movement ME will be clockwise direction. So trim tabs are deflected, delta E in a positive angle of attack, so trailing edge will be down. It will generate force upward and moment MT is anti-clockwise direction, so net moment will be 0 and stick force Fs will be 0. Pilot need not to apply force. This is the primary function of the control trim tab. Okay, just I am going to explain this. You see here, this is the your horizontal tail. Wind is coming from this direction. This is the V infinity, and this is your alpha angle of attack. V infinity, it is in this direction. Okay, so now pilot has applied pull. So by the pulling, he want to increase this upward. Elevator has gone upward. By making the upward, this elevator is generating a force LE downward. This LE here is hinge line. This will generate a moment ME in clockwise direction. Okay, so the elevator which is moved upward by the pilot control, this delta LE into this distance from here to here, it is giving a moment LE into this distance, and this ME is generated. And here delta E is negative. Now this ME has to be countered, otherwise pilot has to apply the force continuously. So how to make that pilot is hand off? Then we have to put a trim tab here. Trim tab is a small aerofoil which is 1/10th or 1/20th of the elevator, and these are the deflected opposite to this. If it is the plus, Here it is a minus, so we have made del T as a plus. This plus will make, it will generate the force in upward direction here. This upward force, which is a delta LT into this distance from here to here. It is a long distance. This is from this hinge line. So a small force, because this distance is more, a small force is required to counter this ME. So this MT will be in the anti-clockwise dice. So this MT is equal to ME. And if it is so, Fs will be 0. Okay, that is the objective of trim tab. Trim tabs are very essential to make pilot relax. Otherwise, pilot has to apply the continuously forces and he may not be able to sustain the, he will be tired and it will not be, efficiency of the pilot will be reduced. To have these things, we need to do, we need to use the trim tabs. Okay. So now further, we realize that delta E float is depend on CH alpha T and CH delta E. Okay, so what is the alpha T? You know, angle of attack of the horizontal tail, and delta E is the deflection of the elevator, and both are negative. Okay, so CH delta T and CH delta E both are the negative. So if CP is behind HL, if the CP is behind HL, just you can see here, this is the your tail, this is your, and here is HL and here is CP, is where your lift forces are supposed to act. So in this condition, delta E float will be minus CH alpha T by CH delta T. This minus sign. So here CH delta E is less than 0, means nose down moment to restoring in nature of as long as HL is ahead of CP. So if HL is ahead of the CP, CH delta E will be negative and CH alpha T and CH delta T both are negative. So we know that CH is equal to CH alpha T into alpha T plus CH delta T delta E into delta E. So in this, no trim tab. Okay, so here this is the floating and this is the counter floating. Okay, so here to make this thing CH, so this your alpha T will make float and this is the restoring force. So one will float, another is restore. So this alpha E will try to restore. Okay, so that is the purpose of. Hope the concept of trim tabs are cleared. Also, what is the basic role of trim tab and how it neutralizes the effect of elevator by giving zero force to the pilot, that is Fs is equal to 0. Pilot can fly the airplane without using any force, called the hands off condition. Okay, that is the objective, that pilot should be flown, pilot should be able to fly hands off condition. Hope objective is clear. Here just I am going to discuss about some visualization and how these elevators are working. So elevator and trim tab operation demonstration. I want to show that how nose down trim. What is the nose down trim? Just you can see here that the first case, here is the, you can see this is the horizontal tail. This is the horizontal tail. This is here elevator. And this is the tab. Okay. So what happens that when elevator is going down, and so it will generate a lift in this direction and it will try to nose down. So it is called the nose down trim. So the function when elevator is down, it means he is putting, the pilot is making push. when pilot is pushing the stick, elevator will go down. When elevator will go down, it will generate a lift upward. This lift will try nose down. So we have to apply a trim tab. Trim tab will go up. So when trim tab will go up, it will generate a LT in this direction. I am making a lift as LT. This LT into, here is a hinge moment, HL. So this XT. So LT into XT, it should be equal to the, here it is LE, and from here to here is, it is a left E, and here is XE. So this LE into XE. So if it is equal, then Fs will be 0. Pilot need not to apply no force by pilot. Okay, so that is the objective of the trim tab. Okay, so here tab is up, so elevator is down. In the next case, when nose up. So nose up means what? When pilot is pushing. When pilot is pushing the stick towards itself, then here what will happen? Force will be this LE. Aerodynamic force will be downwards, and a moment here is XE. So the moment LE into XE will be in this direction, clockwise. So this has to go down. If this is going down, a force, it is called LT, and from here to here, this is the XT. So this should be equal to LT into XT. If it is XL, again Fs will be 0. No force is applied by the pilot, and aircraft will fly without holding the stick by the pilot. Pilot need not to apply any force. Okay. Again, I am just trim tab operation. I am just here. This you can see that nose down trim. Nose down trim means what? Here lift is generated. This will make nose down. So this nose down, here what will happen? It will make lift like this, and it will make like this. So this moment by the elevator will be countered by, this is that tail. So ME by MT, Fs will be 0. And for the nose up means elevator will go up. This will generate here. This is ME will be in this direction. This will generate MT in this direction. So here ME is equal to MT. So no force, Fs is equal to 0. Pilot is hands off. Okay, that is the importance of the trim tab. Very important parameters. We all have to understand. All students of aeronautical should be very much, they should have very much concept clear about the concept of trim tab, concept of the mass balancing, concept of the horn. Today, it is very much essential to understand this all concept. In next class, I am going to discuss about revision of directional and lateral static stability again. Then contribution of dihedral on lateral stability, contribution of sweep on directional stability, derivation of point mass equation of motion. So now we are going to, in the next class onwards, we are going to start the equations of motion, and these equations of motions are very much essential to understand the dynamic stability part. We have done so much about the aircraft static stability, but in the real case, aircraft is not static. It is flying with different maneuvers, different accelerations. So aircraft is in dynamic state. So we should understand the concept of dynamics of the aircraft, and this will start from the next class onwards. I request you people to tune on for the next class also, and it will be very interesting. Every class is going to be very interesting. Please be tuned, join the class, and understand the flight mechanics aircraft stability and control. Okay, thank you very much. These are my references which I am taking from Robert C. Nelson, Aircraft Stability and Control, and then NPTEL lectures of Aircraft Stability and Control by Professor A.K. Ghosh, IIT Kanpur, and these are the login. Thank you very much for joining the class. Hope you will be continuing my class, and any query you can contact me, and thank you very much for joining the class.
Like, share and subscribe. Hit the bell icon for more updates.